Today we'll learn about what we know of dark matter and dark energy. These two things are very mysterious concepts. In fact, for both of them, there is much more that we don't know than we do know. First, let us move on to what we know on dark energy. Dark energy was discovered when we tried measuring the speed at which galaxies accelerate from each other. We found that it is so fast that unless the original matter is not enough to hold it in place. However, we see that these galaxies are normal galaxies. They aren't ripped apart or anything. So that is when we devised that there must be another thing that we cannot detect but is giving some gravitational force, and this gravitational force is preventing the galaxies from ripping. Now 5% of the universe is original matter, 25% is this dark matter, and 70% dark energy. Now, continuing with the dark matter surrounds everything, every galaxy and body, holding them together and making sure that they don't fall apart. And actually 10% of the attraction of the universe is actually 90% of all the gravitational force in the universe, or almost that amount, is from this dark matter. We call it dark matter because it does not interfere with light. Basically, there's no way that we can use light and detect it, because it cannot be like dark stars, because then these dark stars would reflect back the energy. Plus, if it was dark stars, we would have been able to detect it very easily, as these are very big objects, but we can't. So that rules out. They cannot be black holes either, because if they were black holes, these black holes will likely show acceleration disks or stars around them, and thus we'll be able to detect it, which means that we can detect it with light. That rules out the black holes. So it must be some type of subatomic particle that absorbs light and yet gives out a gravitational mass. Like, for example, neutrinos. These things are very hard to detect if they are far from Earth. However, and they are considered massless. At least they were for some time. However, we soon discovered that they're actually not totally massless. They have a tiny bit of mass, and this extremely tiny bit of mass has a small gravitational field. So this might be. But we do know that whatever this dark matter is, it accounts for 25% of the universe. One way we can detect this dark matter is by interfering how light passes around it. When light comes at dark matter, the light just goes around it until it reaches the opposite side and then moves in a straight line again. And if we see where this light path is happening, then we know that in that place there is dark matter. We know that there is something out there too. It interacts with gravity and free. There is a lot of it. But that's just dark matter, and itself, it is pretty mysterious, but not as mysterious as dark energy. We don't even know what dark energy is that much, because we cannot detect it whatever it is. When the universe was expanding, it was thought that it would eventually slow down or either keep on slowing or even slow down to zero and then collapse. That was until we discovered that the universe is not only expanding still, its expansion rate is actually speeding up. We yet don't know what this dark energy is. And again, it has the anti-gravitational force that pushes out the universe. It occupies 70% of the universe, and it does not interact with light. If it did, then we would be able to detect it, but we can't. Some astronomers argue that this dark energy isn't anything but a force that is pushing the universe left from the Big Bang. However, actually, for some time, until dark energy accumulated, the universe slowed down until dark energy took place, and then it started speeding up very fast. Before that point, where it suddenly started speeding up in expansion, it was pretty slow and slowed down. In fact, if it were like that for a few billion years, it might have just stopped expanding. So dark energy took place at the right time, and if it didn't do that time, this universe would likely be a little smaller than it was, because whenever dark energy accumulates, if the universe did go contract a bit, and then dark energy suddenly had an effect and tried pushing the universe back, then it will take some time for dark energy to make the universe expand up again. But whatever it is, this universe is now expanding very fast because of this dark energy, which may as well be an energy, and it is making the universe expand faster and faster. And eventually, in the long future, the universe will likely be expanding faster than the speed of light. In fact, it might even be expanding the speed of light now or faster. But we don't know whether that is the case. All we know is that the galaxies which are near and some galaxies which are very far away we can see, which kind of means that the universe is still far from expanding at the speed of light.